Chapter 1, Exercise 1.121. The U.S. EPA sets limits on healthful levels of air pollutants. The maximum level of lead is 0.15 micrograms per cubic meter. And if the lung volume is 5.30 liters, and then how many lead atoms would be in your lungs, assuming this level. So we have a conversion here from volume to mass, and we have the volume. We just need to pay attention to the units. 1 cubic meter is 1,000 liters. 1 liter is 0.001 cubic meters. So we can do the conversion and get the mass of lead easily in micrograms, and then we convert microgram to grams, and then we convert grams to the number of moles with the molar mass of lead. The molar mass of lead is 207.2 gram per mole. And finally, after we get the number of moles, we convert the value to the number of atoms with the Avogadro constant. So now let's tackle the problem. We have the volume 5.3 liters. Alright, and then divided by 1,000. That will give you the volume in cubic meters times 0.15. That will give you the number of micrograms. Each micrograms is this many grams. So we need a conversion for this microgram. Now we have grams divided by the molar mass. The molar mass is 207.2 gram per mole. Now we have the number of moles. It's a very small number. It's about 4 times 10 to the power of negative 12. And then we multiply this by the Avogadro constant, 6.022 times 10 to the power of 23, and we have the number of atoms, and that's a very large number. It's going to be 2.3 times 10 to the power of 12, because we see only 2 sig figures here. That's why we keep only 2 sig figures at the end. (2.3) times 10 to the power of 12. Alright, let's review the calculation. 5.30 liters is converted to cubic meters. And then we have this volume in cubic meters multiplied by 0.15 micrograms per cubic meter. We get micrograms. And then each microgram is 10 to the power of negative 6 grams. Now we have grams highlighted, divided by the molar mass in gram per mole. Now we have the number of moles. Finally, the number of moles times the Avogadro constant. We get the number of atoms.